Hi, this is Mr. Reese, and this video is going to go into reference angles. This video is a continuation of a first part, and the link for that is listed below in the description. What we're going to do in this video here is we're going to continue on, and in the beginning what we'll do is just simply go over the same old stuff that we did in the first video, and it's going to be real fast. So if you want more depth, you want to check that first one out. After that, we'll go into some more examples, including special triangles, only without using a chart. And it's actually the better way of doing this. If you are stuck with a chart because you're having difficulty grasping special triangles, then of course you'll want to go with that. However, this other method, which does not require a chart, is actually a better method because it's more applicable to other problems. So how about we start off with just the idea of a reference angle. Again, a reference angle is an angle that is adjacent to the x-axis and lies between 0 and 90 degrees. So if you were asked to determine the reference angle for 310 degrees, you would first graph out 310 first. That puts us in quadrant 4. I know we're in quadrant 4 here because as you cycle this way, every time you hit an axis, you've gone 90 degrees. So once you get to 360, we know we've gone too far. That puts us in this quadrant here. The reference angle is always going to be adjacent to the x-axis. That's right here. That means 50 degrees would be our answer. Whereas if you're going to do a negative angle, like negative 210, we know we would be going in the reverse direction, but it's still the same idea in that every time you pass an axis, you've gone 90 degrees. So that puts us right here in quadrant 2. And by the way, if you don't know the numbers, there it is. The numbers are gone according to positive angles, so as you rotate this way, you will pass through each of the quadrants, and therefore we number them in that order. The reference angle is right here, so it's not a continuation to the next axis, but rather what's next to the x-axis by the origin. And you get 30 degrees by taking 210 and subtracting the difference from 180. This is always positive, so that's our answer. Okay, let's take a sidebar here. Let's say you're given something like this. In which quadrant is the sine less than 0 and the tangent greater than 0? In other words, where's the sine negative and the tangent positive? Well, these are the quadrants, 1, 2, 3, and 4. And to determine this, you'll need to keep this in mind. All are positive in quadrant 1. Here, just the sine is positive. Here, just the tangent's positive. And here, just the cosine. To help you keep this in mind, you may want to remember this little sentence, which is, all students take calculus. That is, all are positive, sine, tangent, cosine. So, with this in mind, we have the tangent being negative. That means not in quadrant 1, not in quadrant 2. So now that you've eliminated that, then you just focus on whatever's remaining. Whatever's remaining, tangent's positive. Which of these two would that be? That definitely would not be quadrant 4, where the cosine's positive and nothing else. Therefore, quadrant 3 would be your solution. That matters when you do something like this. Determine the tangent of 190 degrees. Just like before, you want to graph out this angle, 190. That'll be in quadrant 3. Get the reference angle. That's 10 degrees past 180. Now, the idea is this. The reference angle 10 degrees is in reference to an acute angle, meaning the tangent of 190 is going to be the same thing as the tangent of 10 degrees. The only thing you have to figure out is it going to be negative or will it remain positive? So you consult your chart. Right there is 10 degrees. Right here is the tangent. You'd put 0.1763, and then remember, all are positive here, sine here. Here, just the tangent's positive. Since it's the tangent that you want, this answer is going to remain positive. Therefore, that's your answer. Okay, let's do one last one. Then after that, we can move into the new stuff. So the cosine of 120. Just as before, you'll want to map out that angle. That'll put us in quadrant 2. Get the reference angle here. Whereupon then you look at your chart for 60 degrees and cosine. Not this chart here. We're not looking for decimals here. Also note that 60 degrees is a special angle, so that automatically is a hint that you won't have a decimal for an answer. So we really mean this chart here. The cosine of 60 degrees is 1/2, so we would write 1/2. And then, like before, we would try to determine whether it's going to be positive or negative. Just the sign is positive in quadrant 2, therefore this answer is going to be negative. Now again, that requires you to have a chart handy. But what if you don't have a chart? Well, that's going to be for the next set of examples. Okay, let's determine the exact value of the cosine of 210, only without that table this time. Again, just as before, map out that angle. Then after that, just get the reference angle, 30 degrees. Now here what we do is a little different. What we're not going to do is we're not going to consult that chart. Instead of using a chart, what we're going to do is we're going to use special triangles to help figure out the answer. This here is the special triangle for the 30, 60, 90. Opposite the 30 degrees is 1. We call the smallest side 1, and we know the smallest side is this particular side because it's opposite the smallest angle. Opposite the right angle, the largest angle, is 2, which is the largest number. Medium side's 60 degrees, opposite is root 3, which is the medium length. What we do here is we draw an altitude to the x-axis, and it's always to the x-axis. We never go to the y-axis. The reason being is because we want to trap in this reference angle, so we don't have a triangle without it, essentially. Now what you'll want to do is you want to label your sides accordingly. Opposite the 30 degrees is over here. That means that this side here is going to be 1. The hypotenuse over here is 2. That leaves this adjacent side at root 3. Now, a thing about negatives. Let's say that we have the point right here at the end. If you're going to graph this point, you had to have started from the origin and gone sideways. Now, if you go in this direction to graph a point, that means that you went in the negative direction. Then you would have to have gone down. So the coordinates of this particular point would be negative something, comma, negative something. In this case, root 3. So it would be negative root 3 and then down 1 unit, so negative 1. Because of that, we make both of these values negative. And that's key here, because once you have that, then you'll be able to ascertain the cosine more accurately. So now, all you got to use is SOHCAHTOA. That's some old hippie caught another hippie tripping on asphalt. The cosine is adjacent over hypotenuse, so it would be helpful to identify all your different sides. Again, that's opposite, and that's with respect to the reference angle. The hypotenuse is 2, which, by the way, is always going to be positive. These other two can be positive or negative. It changes depending on what direction you're going, but the hypotenuse is never negative. This side would be adjacent. Adjacent means next to, so we're talking about the leg, not the hypotenuse, but the leg that is adjacent or next to this angle. So the cosine, negative root 3 over 2. That's your answer. Let's do another. Let's say we were to determine the cosecant of negative 5/4 pi. Now you can do this in radians and map out this angle, or you can convert this to degrees first. Either way puts you in the same place, which is quadrant 2. That translates into negative 225 degrees. Get your reference angle right here. And just as before, we're going to drop an altitude down right here. Recall we draw to the x-axis because we need to contain the reference angle, which is always next to the x-axis too. Now that's a 45, 45, 90 triangle here, so we have different numbers for this. The smallest side's given as 1, with the largest side being the square root of 2. So let's go ahead and label these values, and keep in mind which ones are going to be negative. That would be this one down here. The reason why is because if you're going to graph this point out here, starting from the origin, you had to have gone to the left first, which is the negative direction, and then up, which is in the positive direction. That's why you're seeing this one being positive, this one being negative. And again, the hypotenuse is never negative. Once you have all three sides of the triangle correctly labeled, only then can you answer the question. The cosecant is the reciprocal for sine, and the sine is opposite over hypotenuse. So we get opposite, which is 1, root 2, which is the hypotenuse. Remember, the opposite side is from the arrow that you draw out from the reference angle. Since it's the cosecant that we want, we just simply write the reciprocal of this. So that's the square root of 2. And that's really it. Now if you're thinking, gosh, that's rather cumbersome, I'd rather use the chart, again keep in mind that this method is more applicable because it stretches into other questions, like what we're about to do right now. So let's get away from special angles here a bit. Let's say we were going to do something like this. Given the tangent is less than 0, meaning that it's negative, and the cosine is 5/13, determine the cosecant. Now the first thing we're going to have to do is we're going to have to draw a triangle, but which quadrant do we put it in? So let's first keep in mind the tangent's negative. Well, where is the tangent negative? Recall that all are positive here, so it's not this quadrant. It's also not going to be in quadrant 3 because here the tangent's positive. So therefore we're talking either quadrant 2 or quadrant 4. That's where we use this. Notice the cosine is 5/13. In other words, not negative 5/13. Just by that very nature, it's telling us that the cosine is positive. Not here either. So therefore, what you would do is you would draw a triangle in quadrant 4. There's our angle, and there's our triangle. Again, note the altitude is drawn to the x-axis. There's our reference angle. Now with respect to our reference angle, we know that, drawing an arrow out, that makes this the opposite side. The hypotenuse is pointing right at, the right angle rather, is pointing right at the hypotenuse here. That leaves this third side as adjacent. So how long are the sides? We use this to help figure it out. Recall that the cosine is adjacent over hypotenuse. The adjacent side is 5, and the hypotenuse is 13. So that's what we label for 2 of the 3 sides. What about this side? Just use the Pythagorean theorem to get that third side. So that gives us 12, and by the way, that's a negative 12. Keep in mind why it's negative. If you're going to graph the point over here at the end, you had to have gone from here to here first, which is positive, and then downward, which is negative. That's why our 5 is not negative, and that's why the 12 is. Once you have all 3 sides identified for the triangle, then you can go ahead and actually answer the question. So what is the cosecant of theta? Recall the cosecant is the reciprocal for sine, and the sine is opposite over hypotenuse. Therefore, the cosecant will just simply be the reciprocal. And that's it. By the way, notice that the answer is negative. That's consistent with this scenario where the cosine is positive here and not the others. In other words, the sine is positive in quadrant 2 but not in 4. It wasn't. That's how it should be. So that's how we know we got these signs right. Okay, how about we do a similar one here? Let's say that you got a point and the angle, the terminal ray of the angle, passes through that point. So determine the sine, cosine, and tangent of that angle. Let's first kind of graph that point. Negative 3, 4 means that you would have gone across negative 3 to the left and then up 4 units. So somewhere over here. Now keep in mind that when you graph this, you kind of trace a path. Like you went across, did you not? Then you went up, did you not? If you return back, you get this triangle. So this right here would be your angle x, and the reference angle would be inside there. Recall that in mapping this point out, you went across 3 units here and up 4 units here. Therefore, that basically tells you how long this side is here on the bottom and how long this side is here on the left. So that's negative 3 and 4. Use the Pythagorean theorem to get this other side, if you can't recognize it, by the way, as a 3, 4, 5 triangle. And then once you have your triangle set up, then you can go ahead and answer your question. What's the sine, what's the cosine, and what's the tangent? So using SOHCAHTOA, that's some old hippie caught another hippie tripping on asphalt, what you get are these. And that would be it. Now if you were asked to determine the other three trig ratios, that's secant, cosecant, and cotangent, you would just simply take these answers and then you'd flip them around. By the way, make a note. The sine and the cosecant are positive. That's because in quadrant 2, the sine is always positive. Now, the cosecant's positive because the reciprocal for sine doesn't change the positive to a negative. So when we talk about all students take calculus, we're also talking about its reciprocals as well. So the sine being positive here, that's a confirmation of it. Alright, let's do one last more. For this one here, in this particular case, we're given the cosine of alpha being negative 2/3. Don't worry about the letters. You can call it whatever you like. And angle alpha is between 180 and 360. So knowing that, determine the tangent of alpha. Just like before, we need to draw a triangle first, and then once you do that, get the length of all the sides before you determine the tangent. But we have to know where to draw that triangle. So the cosine is negative. Recall that cosine is not negative in quadrant 1 or in quadrant 4. That means that you're going to be drawing a triangle either in quadrant 2 or in quadrant 3. Notice that the angle is supposed to be between 180 and 360. That means that you will have gone past quadrant 2 first, and then you will have drawn this triangle either here in quadrant 3 or here in quadrant 4. We already know the angle is not supposed to be in quadrant 4. That leaves us in quadrant 3. So let's go ahead and do that. Right there is alpha. There's the reference angle for alpha. And there's our triangle. Remember, the altitude is drawn to the x-axis because it's got to make use of this reference angle. Recall how we identify all our sides. That's the opposite side. The hypotenuse is being pointed at by the right angle. That's over here. That makes this side the adjacent. The cosine is negative 2/3. Remember, cosine's adjacent over hypotenuse? That tells you that the adjacent side's 2 and the hypotenuse is 3. So which of these two is supposed to be negative? After all, it's got to go somewhere, right? Well, it can't be here. Remember, the hypotenuse is never negative. That means your adjacent side's got to be negative. Now, if you think about it, that does make sense, because if you're going to be graphing the point over here, you had to have gone in the negative direction first, then down to reach this point. The Pythagorean theorem would make this the square root of 5, and by the way, that's negative. And again, once you have all the values for each of the sides, then you can go ahead and answer the question, what's the tangent? The tangent is the opposite over the adjacent. Some people refer to it as rise over run. In other words, the slope. So that would be negative root 5 over negative 2. And oh, by the way, the negatives reduce out. So that's your answer. And by the way, note that our answer is positive, as it should be, because again, the tangent's supposed to be positive in quadrant 3, which is where our triangle is.